Thank you for being here for the SQAB tutorial. It is my real pleasure to introduce my colleague Shawn Gilroy for this tutorial. Shawn, first and foremost, is a Temple University analyst, one of our students, and he has already done quite a lot of very, very good work. I want to tell you a little about what Shawn, his background, what he is and what he is not. Shawn right now is a Marie Curie Fellow, European Union Fellowship based in Ireland, National University of Ireland, Galway. And he'll be returning to this country very soon, permanently, to take a faculty position at Louisiana State University. Before he got to Ireland, he was a pre-doctoral trainee at Monroe Meyer Institute. He did a postdoc at Kennedy Krieger. And Shawn is a school psychologist, a researcher, a practitioner, a consultant, a scholar. What Shawn is not is he's not a computer scientist. And that's important, because this whole talk is about why we collectively need to get more involved with development, programming, and such. It's important to keep in mind that this is coming from an applied researcher, not a computer scientist. And if you're listening to what Shawn has to say and your covert behavior starts drifting to the, oh, that is way, way too complicated, I can't do this. You know, we're behavioral scientists. And to kind of put it in perspective, in 1960, President Kennedy said that we were going to put a man on the moon by the end of the decade, and he also said that we were going to pretty much take care of prejudice and discrimination. And in undoing both of those, we're going to have to really upgrade our computer knowledge infrastructure. Well, as we know, in 1969, Neil Armstrong stepped on the moon, and that same month, there were race riots in Detroit. Today, whenever there is a rocket sent up into space, it doesn't even make the newspapers. You get a real space geek to find these things. Each of us has in our pocket a computer that is more powerful than all the computer technology that existed. In this world, we put a man on the moon, and we still struggle with issues of prejudice and discrimination. So whenever people get snotty, I point out to them that, you know, rocket science, computer science, that's easy. Behavior science, that's hard. So just got to keep that in mind as Shawn tells you about why we should get involved in writing our own software for our own purposes. Shawn Gilroy.
Excellent. Good morning, everybody. Thanks, Don. My name is Shawn Gilroy. I'm a research fellow. I'm currently out in Ireland. My background, I'm primarily a clinician and an applied researcher, but I just so happen to also do a lot of computer programming, mainly in the area of application development for Apple and Android. So today, our plan is to talk a little bit about not so much specific interventions, but really why open source is a relevant theme that I think we as a field should embrace more. For the objectives today, our plan is to provide an overview of what free and open source software is. We're going to also review an example of free and open source software, something that was published and reviewed in our venues, in JAB. And we're going to talk a little bit about how we could use this free and open source kind of model as a way to help disseminate some of our methods and some of our science and close a little bit of the research to practice gap that we sometimes see when we develop some more advanced methods. So this first line that comes up on this slide, this comes from the general public license, which is one of the most common free and open source licenses. And it starts with, when we speak of free software, we are referring to freedom, not price. I always really like this line because when I see when we speak of it, it makes me think of Heinlein. So it's this really kind of close connection. So like we're kind of like have a little bit of the same message. So freedom in this sense means that when software is free and open source. We can use it, we can reverse engineer it, we can change it if it doesn't quite fit for us. And we have the freedom to share our changes back. So there's this back and forth reciprocal nature between software and the community that uses it. Free and open source software is great for open access and collaboration. The example I'm going to review here is really interesting because I think it's been in development for about 2 years. And for 2 years, I never actually was in the same room as any of these people. I'm in Ireland, a whole lot of behavioralists in Ireland. But through the free and open source software movement and the tools that are out there, we're able to collaborate on these really interesting projects that have really good impact. There are some other desirable qualities of free and open source software. It's affordable, it's sustainable over time, it's customizable, especially when we have really complex cases, things may not fit quite as well as we wish they would. Things are transparent. There are no secrets in free and open source software. It's completely out in the open, everything's visible. And it also grows with support from the community. So people who work on free and open source software, there's a lot of players involved, there's a lot of collaboration, and it's very open and sustainable. I would note that the license I talked about there, GPL, that's just one type of free and open source license. That's one of my preferred options, but there are a lot of different licenses out there. So, why should this matter to us? I'm pretty sure just about everyone that works clinically out in the field can realize there's not very much designed specifically for behavior analysts. And what we usually say is we have to find something, it's usually Excel, that we have to cobble together to give us the functionality that fits our clients and our needs, because there's not really much out there that's built for us and for our work. As a result, few things off the shelf really provide the type of analyses, the type of methods, the type of figures, the type of things that we would want to see right away. For statistical means, you're not going to find any matching equations in SPSS anytime soon. We just don't have that presence in those major software packages. So if we want to do these analyses, we're often going back to Excel, or going back to the things that are accessible to us, because there really aren't many solutions out there that are designed specifically for us. So there are some free and open source packages out there, which is really great. It's happening more and more. And what's interesting is the few things that were designed for us were actually made by other behavior analysts. So these are people that develop their own technology, use it in the context of their practice or their research, and share it back. But what's interesting is it didn't come from a software company, it didn't come from some crazy statistician, it came from behavior analysts using this stuff in the field and putting it together themselves. So there are a number of free and open source packages that are already out there, which is really interesting. I actually think most people don't hear about it as much, but I'm hoping that it begins to gain more visibility because there are really good tools out there. Most folks that are in some of the severe behavior programs are probably familiar with one of the options for electronic data collection out there. The first one that comes to mind is BData Pro, Dr. Chris Bullock's program, which a lot of people use. It was actually submitted to Perspectives in the last year. So this is a peer-reviewed piece of software that was designed by a behavior analyst to be used in behavior analytic work, which is really cool. Via demand, we are developing some statistical tools that provide the type of analyses that we as a field come to desire. Via demand is being developed by Dr. Brent Kaplan, and the focus is on operant demand, and operant demand in the context of performing these analyses in R. And the example that you see that I shamelessly put on the side is one of mine. I run clinical trials in Ireland where I develop technology that's used by children with communication disorders. And I'm fortunate that I'm able to develop the FastLooker app open source, and I actually use BData Pro in my own assessment procedures. So free and open source, it's active in behavior analysis. But I think it needs to have a little bit more visibility. As I noted before, BData Pro was published in Perspectives. This is a tool that's widely used in a lot of severe behavior programs. Again, I use it in my own trials. What's really great about this type of approach is once these type of projects are submitted to peer review, these things go through the peer review process. They're vetted by behavior analysts, they're vetted by researchers, and it's archived online, which is great from a replication standpoint, because if you want to have good, reliable tools, it's great when it's centrally managed, it's securely located, and it's managed by researchers, and it's updated over time. What's also really great is people can go into searching for articles, and right in the article there's a link to where the source code is and where the program is, and it's accessible even for practitioners without trying to get into that. Shamelessly plug my own program again. At least for my area, which is in communication disorders, there's a lot of variability in terms of the types of applications that are developed for kids with autism and for kids that are in behavior analytic type of interventions. I ended up having to develop an app for my trials because most of the apps out there, I can tell a behavior analyst didn't make it. There are things that I want to do, there's ways that I want to manage the field as a behavior analyst, but since that behavior analytic viewpoint isn't built into how that was designed, that was an issue. So that led us to develop this app, which has been a really fascinating project over the past 3 years because I have my students and my people working in the fields. If there's ever an issue, they log it on my GitHub, so I know that I need to update something in the source code base to fix an issue or to add a feature, and it's great. So over the past couple of years, people have been able to field test technology, to raise issues, to let developers know this is something that as a behavior analyst I would want or I would need, and we're able to kind of update that and grow that way. And it's been really great because using this kind of open kind of co-development kind of model, we're able to really make sure the technology that's out there and being made really reflects behavior analytic practices and the things that we would want to do. So like being able to do within STEM modifications to support a range of different responses for technology and to manage the type of controls that people would like when they're actually running session. For the example that we're going to go in today, today's not really about delay discounting, but for the example we're going to review today, we are going to use an example of a delayed discounting program. Free and open source software is well suited right now to help improve the accessibility of statistics for behavior analysts. So there are a couple things right now that are becoming to be more and more popular, especially in behavioral economics. There's more consumption of more advanced methods, and more we see people using things like model evaluation, multi-level models, and people are starting to put together these tools. What's really great with behavior analysts jumping into the fray and actually developing it is we're able to build it in a way that helps improve our own accessibility to statistics. And we're able to do it in a way that's affordable, especially for people that are working in applied settings. And what's really great is that some of the flagship journals in our field are also becoming more and more receptive to accepting articles that are software-based, and these things are able to go through peer review. So that brings us to our example here, which is the discounting model selector. Has anyone ever heard of this stuff? A couple people? Okay, good, so it's fresh. So the discounting model selector was something that myself and a couple of colleagues put together because we realized there was a bit of a gap in terms of the types of tools that are available and accessible to behavior analysts and the type of recommendations and things that we're seeing kind of in the field and in the literature. So for the sake of the DMS, it was designed to simplify a couple different types of statistical operations that are particularly challenging to perform, especially if you're not a computer programmer. So for the sake of the DMS, the focus was on model comparison. represents in model selection. Again, this requires some level of programming skills to perform and some statistical training. It's also particularly time intensive. I think right now in that rotation there's 10 models. So if you wanted to perform this operation, you could probably have a page worth of code, and you have to be able to understand it to get that to work. So what the DMS does is it takes this complex operation and it makes this type of procedure much easier to do. We'll go through that a little bit more. What I really like about this as an example was it was something that was made specifically to be used by behavior analysts. And what that means is most behavior analysts are not people that are going to fire up a console and write computer code. That's just not the type of experience that we normally have. But we are used to dealing with Excel and just operating in that kind of framework. So that's how the DMS was constructed. It was constructed to look like you're opening Excel, interact with your spreadsheets that have an interface that is familiar to us, because it's tailored to us. Everything operates by point and click. All the settings are very visible, things are very well explained, and you can do all these types of operations without having to be a programmer. What I really like is self-updates as well. So that doesn't just mean when things go wrong or there's a bug. When there are new methods, when there are new analyses, when there are new metrics, all the updates are streamlined. So a program like this is well suited to us because it kind of gives us everything behavior analysts would want from where the field is in this area. And it'll do it in a way that always kind of keeps you up to date. What's really interesting or really great is that this tool is free and open source. So it's great, I mean, if you just want to download it and you just want to use it, that's great. But what's really cool is if you want to download the source code and build it yourself, you could do that. Everything's kind of laid open where if you want to take a tool like this and adapt it to matching equations or some other type of mathematical thing that's going on in behavior analysis, the source code is there and it's documented, and you have a lot of tools to kind of tweak it to suit your own needs, which is a great starting point if other people want to build other tools to support certain type of things. Even if you don't want to kind of develop your own thing, what's really great is this is archived online, so there's a lot of opportunities to use the program, and if there are things that either aren't working the way you want, there's a lot of opportunities to submit bug reports, to kind of give some feedback to developers, which is really just me. It also gives you a really great running list of the type of things that are being added, why they're being added, and the links to the peer-reviewed articles that kind of inform why the program does this way. It's really great because all the code is transparent. We know where the code comes from, who writes it. It refers back to a published article that's been peer-reviewed, and all of this is accessible online. I'm sure most people are familiar with delay discounting, but I'll just give a quick review. Delay discounting refers to a pattern of preferences over time. And when we run these type of experiments, usually what happens is we collect some data, either through in vivo choice measures or questionnaires, and through whatever process we go through, we have some type of indifference points as a result. And there's a lot of different ways to do that. But as you see in this figure, it doesn't end when you have the indifference points. There is no shortage of options for trying to quantify what this process looks like. This becomes really, really complicated when there are 10, 20, there's dozens of discounting models. And there's just a lot of options to do with this data. So some of the popular options that are out there, pretty sure most people are familiar with measures K. There are hyperboloid models, which are dual parameter models. There are empirical measures, such as AUC. We have cross-model type of methods, like the effective delay 50, which is something you can use across most models in most cases. And there's also model-based AUC, which is a relatively newer type of analysis in delay discounting. And what that really means is it's an AUC metric that instead of referencing the data points, it references the actual most optimal model. we can chat about later. The takeaway is there's a lot of options out there. There are a lot of different type of ways to break this down. And what's really challenging is without a centralized resource, you almost need to build a specific tool to do each and every one of these. So that usually means that you have to have spreadsheets made up to do AUC, you have to have spreadsheets to do ED50, spreadsheets to do log scale AUC. And for a model-based AUC, unless you're a programmer, you probably can't even do that. So that kind of leads us into our next slide is what are the tools available to do this work? This is not an exhaustive list, but these are some of the things out there that people are using. There are commercial statistical tools. I personally really like MATLAB, but there's also GraphPad, Stata. Some people are using those. There are some free and open source packages. R is getting more and more popular in behavior analysis. But there's also Python, SciPy, Octave. Octave is the MATLAB complement that's open source. And then there's good old Excel. Everyone uses Excel. What's kind of challenging here is there's really very few free and open source statistical programs that you could do a whole lot with without having programming skills. R is incredibly robust, but the learning curve is quite steep because it's syntax driven and it requires some level of programming skills to really kind of get much out of it. So, looking at this gap, we see that there's a lot of free and open source software out there, but for behavior analysts that aren't programmers, this is a very steep learning curve, and there's no real stepping stone to helping behavior analysts get into using more free and open source software. So this is what led to why we wanted to do the DMS, because we wanted to have free and open source stuff that is consumable by behavior analysts that aren't programmers, and we wanted to do it in a way that's free and open source, but it also kind of fits with how we're used to working with data. So some of the specifications we had was we wanted to have free and open source software that did all the operations we would need to perform delayed discounting analyses. So that's model fitting, that's model comparison. We wanted it to be able to offer all the metrics most people would want from delayed discounting studies. We wanted to have them all in one place. So if you wanted to have individual parameters, that's great. If you wanted to have ED50, that's great. If you wanted to have this fancy new model-based AUC, it's all there. You have the option to kind of have all the analyses that behavioral analysis right now has to offer, and you have it in a way that's free and open source, that's very accessible, and it's stored in its peer review. We want everything to be presented in a graphical user interface so that there's a lot of opportunities for good documentation and good transparency so that people really understood what they were doing. And lastly, we want everything to be managed open source so that reviewers and people in the field can inspect not only the manuscript that outlines, but also go into the source code and inspect how things work and the conventions that go on there. That's actually a pretty cool figure of what model fitting looks like for rapid model. So what's really interesting is it's actually not that hard to put together programs anymore. 20, 30 years ago, before open source was a big thing, that'd be a large feat, but right now, the tools for putting together these programs are really out there, and they're totally free, they're all open source. So I only really needed two packages to build this entire program. One is a linear algebra library, AlgebLib, which is a preference of mine. It uses a gradient descent kind of approach, which is what we would use to optimize the discounting functions we normally use. And we made the interface with the Cube framework, which is an old, tried and true open source UI toolkit. It's been around for a while. And the whole thing was written in C++, which is great because what that lets us do is C++ is it's very fast and it's very portable. So we wrote it in a way that it'll run on Windows, it'll run on Mac, it'll run on your phone, it'll run on a server, it'll run on just about anything. It's fast. I will note that we're going to talk mainly about gradient descent types of optimization today in terms of what the DMS does, But there are other options that the DMS provides that helps address some of the more challenging types of data and models we have to fit to address convergence issues. And those are the genetic algorithms, but we'll get to that at the end. What's really cool is if people wanted to just download and install the program, you could go right to my website. It's Small and Stats. That's where I put all the installers on there. I'll have more links to the stuff later, so I'm not right now. But if you just want to install it and run it, you just install it like a regular program, and it's ready to go. So anything that's stable, anything that's peer reviewed, that's what you can download the program. But if people wanted to get daring and try brand new features, things that are in kind of the preprint stage, they could build the source code, or they could build a program with the source code, and they get access to that pretty much anytime they want. Which is really, really great because I'm able to collaborate with a lot of people across the world that do this work, and we just all kind of interact with the source code, and it kind of gets developed in that collaborative, simultaneous way. So if people ever wanted to look at the source code and see how that operation works, you can go right onto my GitHub page, which is where I host all of my projects. And everything is up there with instructions on how to get started. You could also file bug reports and tell me you hate the program and all that stuff. You can do that on there too. These are the two places where I host like either the installable binaries or the source code. Small and Stats is where you would go to download the installers, but there's also on there documentation, descriptions, background on how programs work and how they're made. And there's also a lot of really cool web-based tools. Since I wrote it in C++, there's a web-based version of all of that. There's even a way for you to fit discounting mouse on your phones right now, but we'll go into that later. So that's at Small and Stats. If people ever wanted to see where I keep my source code for all my projects, you can go to my GitHub, right there. So this is where I keep the source code for everything that I work on. So for all the publications that are out there, the things I do with discounting, demand, escalation, my simulations, everything I really do, it's up there. So if people ever wanted to recreate my work or see what my data look like or look at it their own way, it's all kept up there. So if people ever want to go and recreate any of my analyses or see kind of how I put together programs and how it performs, everything you would need to recreate all my work is up there. And this fancy graph kind of shows you how I probably work on this stuff more than I should. So we're going to jump into a case example now of something that we use the DMS for. So there are some things that folks are looking at in terms of decision making, in terms of like caregivers and their preferences for types of treatments. Nick Hall did a couple of papers on this, which is really interesting. What this really looks like is the parents, do their preferences and perceptions change regarding interventions when the effects are temporally delayed. So behavior analysis is a great framework for interventions, but it really doesn't fix the problem right away. And there are times where sometimes the perception of how long it's going to take may discount the value of that intervention versus some other quicker or less substantial one. So Ken Shanley and I at Rochester Medical put together a feasibility trial to see if we could look at this type of decision making in the context of parents going to outpatient behavior therapy and to try to evaluate their perceptions of delays. So what that looks like is we put together this experiment, and what we were doing is we were trying to assess the impact of delays on parents' preferences for behavior treatments. It's an animation of the app that we gave to parents to collect the data and the indifference points. And it runs your standard fry titration, adjusting amount and mask. So what we did is we put we took caregivers that were participating in outpatient behavior therapy, and we sampled their temporal preferences for types of treatment, and we got, I think, either 60 or 70 data points, just as a feasibility trial to see if we could reliably get the type of data that people ever want to like fiddle with this program, that's also on GitHub. If you ever want a way to assess decision making, quick and easy with a tablet, that's also on there. So this is what the discounting model selector looks like. And there's really not a whole lot to it, and that's by design. So really all you have to do is once you have your Excel spreadsheet with your difference points and your delay points, really all you're doing is you're selecting the file, you're picking the file, and once you pick a workbook, it's just going to say, tell me what worksheet you want to pull data from. And once you indicate that, it's into the spreadsheet, and then from there, it's just point and click. So you're picking your delays first, you're picking your range of difference points, and you're just specifying whatever the maximum value of that commodity was. I think in this one it was maybe 1. From that point, you just say what models do I want to consider and what measures do I want, and whether or not you want like screenings for systematicity. But once you check those boxes, the only thing left is just to hit calculate, and all your answers are there. So it ends up being really easy. So you could run model comparisons for 10 models right away without having any programming skills, without really knowing the intricacies and the challenges that go along with fitting models using an optimizer. And you can do it really quickly. So for this study, what we asked the program to output was give us ED50s, give us the model-based AUC, and give us the log-scaled model-based AUC. And just looking at the options that came out of DMS, what we saw was it looked like the log-scaled type of the log-scaled index of discount looked like it was the most normally distributed of there. So were we using this as part of anything but a feasibility trial, this is probably the type of measure we would use when we want to compare it to a different sample. But all in all, and again, this is probably not. There's probably a lot of different ways to decide which type of metric you want to use, but this is just one. Since the DMS gives you a handful of different options, it's kind of up to you all to kind of decide which measure is most appropriate for your question. So what's interesting is, if folks really wanted to try this, you can go right on your phone right here, and it'll run on your phone. So if you ever have delayed discounting data, and you're like, I just have one person, I want to get what that number is, you could actually pull it right up on your phone. And you just put your values in here, like your delays values. They have to be between 0 and 1, so that they're already divided by the max value. And then from there, you just hit a button, and it'll perform all the analyses you would need for, or all the analyses you would get from this installed computer program. It's done in the way that you could do it on an iPad, you could do it on your phone. There's a lot of access to be able to get these methods. So if people want to fiddle with it, you can go right to that spot on your phone. If you just say, look, give me some sample data, we'll just throw some sample data in there and hit calculate. And what it'll do is it'll do model selection. It'll tell you what the most probable model is for that data, and it'll give you a metric, I think ED50, model-based AUC, and then the scale AUC. But again, really easy to do, very accessible. So that's cool. But for some people, the whole cross-model type of approach, which I'm exploring right now, that may not be for everybody, and that's fine. There's a lot of different ways you could use the DMS. What's really helpful is, even if you just want to run checks for systematic responding, you can go through and it'll run the Johnson and Bickel criteria for you, just to kind of eyeball, what does your data look like in general. If you want, you could use it as a general purpose modeling tool. So if you ever have tricky data that you don't really trust what R is giving you or the program, you could put it in there and just get the estimates for your model across a range of options. And it also gives you a number of extra goodness of fit measures that you may or may not get out of the box with some other programs. There is a group level kind of aggregate fitting option that I'm probably not going to get to until I get back home. That's also under that. If you just want an aggregate idea of what model best fits this group and have a couple that's also cool. So we have this stuff. Why is it interesting? What's next? The free open source technology. I think the DMS is a good metaphor of why we should try to maintain this approach, where we're developing technology that fits with us, it fits the type of analyses we want, it fits the type of users we are, it fits how we would actually use it in the field, and it's done in a way that it updates and it's going to help maintain and support users as new methods and more advanced things come along. It's really interesting because even having this centralized resource, when new models come along and new metrics come along, we can update the program, and that would improve dissemination, especially as the tools get more and more advanced. And yeah, since it's frequently updated and it's managed and bugs are constantly being fixed, it's something that will last and be available for free. Beyond the whole free and open source things, there are a couple things that I think are going to be helpful for delayed discounting research. There are some pretty sophisticated types of methods that are very suited to delayed discounting, but sometimes these are particularly challenging to implement. I am very excited to have more genetic algorithms in terms of model fitting. Genetic algorithms are a very interesting approach, and it's really well suited for issues where there is a global minimum and a lot of fake local minimum. And in some of our two-parameter models, a lot of times we see there are odd cases when convergence is very dependent on where our start values are. So in certain models, especially models that have difficulty converging in some cases, this type of approach tends to be very robust, and it handles those problems really well. Also, having more than one optimizer in the program is especially helpful when you have really challenging types of data that are just particularly, well, they're not converging in most of the programs. What's also interesting is adding more and more model candidates. There's a lot of types of discounting out there. There's delayed discounting, but there's also effort discounting. There are a number of interesting psychophysical experiments where people are using this type of framework, but it's not always about the time. So by adding more models into the model selector, we entertain more of these models. And we also broaden how versatile the program is, where it's great for delay discounting, but it's also applicable to things like effort discounting, which may be introduced in the literature with a different model. There's even some more advanced models. Lakerock actually has three parameters, which is really interesting. But in this way, we have a lot more options when we go in and try to test a research question. These are some of the ones that are being considered, and there's still a handful more. There are really dozens of these types of models out there. The DMS is really interesting because the new model-based AUC metric that's out there, it's very hard to find a program that natively would perform numerical integration, the type that we would want in delayed discounting. And it's even more challenging when we want to scale that linearly, like how folks have scaled AUC in the past. But by having this built into the DMS, even people that aren't programmers, this robust type of method is just part of the program. You don't have to learn anything extra to be able to perform. So, next steps. This is great for discounting. This is great, all that stuff. But I'd say free and open source has a lot to offer behavior analysis in general. This is just one example of a free and open source project and how it can be developed and maintained to fit us and how we use programs. But we really should be striving towards this in many different areas. So we could develop technology to help us address some of the methodological and organizational and pragmatic things that come along when we're practicing in the field. What's also more interesting is if we were to adopt this a little bit more, this may also help to speed along more translational work. Translational work often requires more specialized types of methods and more specialized approaches, but by having technology that's designed by behavior analysts, that may actually become more feasible to use in the field. I'd say, lastly, by developing our own open source, we kind of take a little bit of the control of what's suitable for our field, what do we think we need. If we were to encourage this and support it and make it part of our peer review process, we have a lot more control instead of just waiting to see what private industry is going to kind of give us and then have to kind of make it work. So I'm kind of hoping that becomes more of a theme in our publications. So, in closing, free and open source software, this movement is happening in behavior analysis. There are a lot of types of good work happening now, and it's growing. But if I could say anything, it'd be we should jump in at first. I think people should be trying to build their own software, trying to explore programming, and once they refine these methods, I think it's ready for a peer review if it's something that genuinely helps our field and genuinely can be used by other people. So my recommendation would be use open source, explore these options, and if you're brave, try to learn a programming language. You'd be surprised how much easier it can make your life if you know how to automate a couple of things. And if you're going to learn a language, what I would say is pick, I'm a fan of the C languages, but just about any of these modern languages, you could do a lot with those. Before, these were these slides of their resources. So if people wanted to have any of the opera-demand software, the delay discounting software, electronic data collection, any type of projects that have been peer-reviewed and put out by me and my colleagues, you can download them right from the website just like a regular program. It works for Apple, it works for Mac, it works for Linux, but I don't think it use Linux. It also gives a really good listing of all the projects that are going on, where they are, and there's also really cool web-based examples of modeling tools. So if you're ever like, I'm not brave enough to install this program, but I kind of want to go on my tablet and kind of see what the data looks like and how it works, you could jump right in there and use the web-based examples and get your feet wet there. For the genuinely brave people, I would say jump right in, download the source code, follow the instructions, see if you can build it yourself. If there's something that you want to do, tweak it, and if you really like what we've done, feel free to try to share those changes back on GitHub and kind of help us kind of grow the community of developers. There are more and more programming behavior analysts out there. I hope more and more do pop up. Again, if you ever want to see any of these projects, you can download them. Anything that is peer-reviewed, the scripts, the raw data, everything you would need to recreate the publications and how these tools were validated and put through peer review, all that's on there. So if you ever want to just explore, everything you would need is right up there. From there, I guess, I'd just like to acknowledge a lot of the people that really helps with this work. Chris Frank was the original guy that helped or put together the model section routine. So I think that was great. And most of the other folks have been really helpful in trying to put together their software and make it something that is very accessible and useful to behavior analysts. Thanks, anyone? Anyone have any questions?